Hey guys, how's it going? And welcome to this tutorial on how to write a C++ program for bisection method, which is basically a root finding method. And before we start this tutorial, just keep this in mind that this video is gonna be pretty long since we'll be covering the algorithm, the flowchart, and then we'll be going to the program part of the tutorial. So in case you only want the program, you might want to skip ahead and jump to the program part right away. Now coming to the algorithm, just like any other numerical method, bisection method also requires some initial guesses, but this time it requires two initial guesses. So first of all, let's say we have an equation f of x and we want to find its root. Then what we want is we want the user to enter some initial guesses a and b such that the actual root of the equation lies between these two initial guesses. Now you might be wondering, like sometimes I may have an equation that and I don't know where its actual root is gonna be, but don't worry, we'll construct a condition so that if you enter some wrong initial guesses, the program will prompt the user to enter a different initial guess. Alright, so that part will be taken care of. Now the second step is to ask the user the accuracy of the result, and it is represented by EPS, which stands for epsilon. Now what I mean by accuracy is that let's say the actual root of an equation is 2.345689, alright, and let's say the user entered an accuracy of 0.001. Now what it means is that the computer can return a root that would be correct only up to 2 decimal places, since we have 2 zeros here. So if the user enters this accuracy, then the computer might return a result like 2.34 and any other number after that. Alright, so that's what accuracy means. And if a user enters an accuracy of 0.0001, then the result that the computer returns would be correct up to 3 decimal places. Alright, so just keep that in mind. Alright, so let's move on to the third step, which would find out whether the initial guesses that the user entered were correct or not, that is, the root lies between them or not. So what it does is it calculates the product of f of a and f of b, the value of the function at the two initial guesses. It calculates their product, and then it checks if the product is less than 0, that is, if it is negative or not. Now if it is negative, then we can continue with our program, because it means that the root lies between a and b. Otherwise we'll have to ask the user to enter a different value of a and b. Alright, so we'll make this if condition in our program. Now the fourth step is pretty easy. We will just check if the absolute difference between a and b is less than the desired accuracy or not, and if it is less than the desired accuracy, we will end our program. So let me just change this condition. It should be greater here. Alright, it should not be less. So y a minus b, the absolute difference between the initial guesses is greater than the desired accuracy. We will calculate c, another value, which would be half of the sum of the initial guesses, and then we will calculate basically this step is exactly what bisection method is doing. This is what bisection method means. So I guess you would already know that if you are going to make a program. So you calculate a bisected value, that is c, which is half of the sum of a and b. Then you calculate and see if f of a, if the product of f of a and f of c is less than 0, and if it is this way, then we make b equal to c. b, which was the second initial limit, and we make that limit equal to c, because if f of a and f of c, their product returns a negative number, that means that the root lies between a and c. So we need to change the second initial guess to c, because the root lies only between a and c. However, if it is not the case, then that means that the root lies between c and b. Therefore we make a equal to c, because the root lies between c and b. So that is basically the bisection part, where we will be doing the bisection, and we will choose this process on and on until the absolute difference between a and b becomes less than the desired accuracy, and if it is greater than the desired accuracy, then we will keep on repeating these steps. Then finally, when we find the, when a minus b is less than EPS or equal to EPS, then we will have our root that is stored in C. So we will print C, which is a required root between A and B. So that was the algorithm for the program. Now let's come to the flow chart. So we start the program, have the user enter A and B, which are the initial limits, then have the user enter the desired accuracy. Then we have we calculate whether the root lies between A and B or not. If f of A into f of B is negative, then we continue with our program. Otherwise, we ask the user to enter A or B again, as you can see right here. So if it is negative, that is the root lies between A and B, then we find C, which is half of the sum of A plus A and B, and then we move on to the next step where we calculate if f of A into f of C is less than 0. If it is true, then we make B equal to C, otherwise we make A equal to C. Then we move on to this step where we check whether the absolute difference between A and B is less than the desired accuracy or not. If it is less than the desired accuracy, then we just go ahead and print the value of C. Otherwise, we go back to this step where we calculated C, and we'll calculate C now with new values of B and A, depending whatever they turned out to be. So that's the flowchart for this program. And let me just cover another point in case you are wondering, like, how can I tell if the root lies between A and B by checking this condition? How does this condition tell us that the root lies between A and B? Now I'm pretty sure you might know that, so but still I'm going to cover that. So let's say we have a function this represented by this orange line, and this function is f of x, alright, and let's say the user entered these values of A and B, alright. Now we can clearly see that the actual root of the equation is the point where f of x equates to 0, which is represented by this blue line over here. So this is the point where the value of the function is 0, therefore it is an actual root. Now clearly this actual root lies between A and B. Now how I can check that mathematically is, now if you see this purple dot which represents f of A, that is value of the function at A, and this purple dot represents f of B, that is the value of function at B. Now clearly f of A lies in the fourth quadrant, that is the negative region, and f of B lies in the first quadrant, that is the positive region for this line. This line is f of, sorry, I can't write with my mouse, I guess, f of x. Alright, so this y-axis is for f of x. So clearly f of b is a positive number and f of a is a negative number. So clearly their product will be negative, and that is how I can tell that the root is going to lie between a and b. Alright, now let's say the user entered some other value for a, that is this value. Now let's say the user entered this value for a, alright. Now clearly if you see that f of a is also positive and f of b is also positive, therefore their product will be positive, and clearly the root doesn't lie between these two values, a and b, the root doesn't. So that's how we can physically interpret this condition. That's how we can understand in our mind that if this condition is true, that means that the root lies between a and b. Alright, enough of algorithm and flowcharts. Now let's jump ahead to our program. That is what this video is for, after all. So let me just make it full screen, and we'll be doing it on Linux, Ubuntu to be precise. Alright, so here I have this bisection method program for C++. Now just included some basic libraries like input, output stream, math library, and I included this math library because sometimes I might have to use square root or power functions for the equation whose root I have to find. So that's why I use this CMath library. Okay, so first of all, define a function f and make sure you define it as a double, because a function can return almost any value, and also make sure that it has a double argument. So here we are defining a function f of x basically, which would be the equation whose root we have to determine. Then here is we are going to define the equation whose root we are going to determine. So let's say I have to find the root of x square minus 4. We know very well that the root is plus and minus 2. So we'll have this function f of x return this equation whose root we have to find. So clearly I defined a to be x square minus 4 and then I return that value. Alright, now let's move ahead with our program to the main function. So here I have set the precision with which the numbers will be displayed on the output screen. I have set the precision to be 5 so that only 5 digits after the decimal place are displayed. So these two lines are for setting the precision of the output. If you don't use these lines, then if the computer wants to return something like 2.345678 and up till I don't know how many digits, but it's gonna display like 10 or 11 digits if you don't use the precisions, and I didn't want that, so that's why I set a precision of 5. Then I declared some variables that I will be using in throughout the course of the program. Then here what I have done is I have set a label A because I used a go to statement in the program right here, which is not very good from a programmer's perspective, but since I only needed this function, program done for my numerical methods class, it wasn't very important to create a very good program, like programmer wise. All we had to do was create a program that would work for our purposes. So I used a go to label here. So this A is actually a label which will tell the go to statement to go to this whenever this go to A is called. Anyway, so then I asked the user to enter the initial limits. Okay, so and then the user entered A, then I asked the user to enter the initial limit B, then the user entered the initial limit B. Then I asked the user to enter the degree of accuracy that is required, then the user entered the accuracy and it is stored in a variable E. Oh, alright. Then I created a variable it's iter, it stands for iteration, so for iteration 0, alright, and then I checked whether the product of f of a and f of b is greater than 0 or not. If it is greater than 0, then that means that the root does not exist between a and b. So we'll have the user enter a different value of initial guesses and we will go back to this a step from here, alright, because the root doesn't lie between a and b, so we'll go back to this step. Else, that is, if the product returns to be negative, that means that the root does lie between a and b, then we'll go to these steps. That is, these two lines can be avoided because not avoided but can be ignored for now because these are just for setting the names of the columns. For example, when I print the output, you can see that we have this column called iter that stands for the iteration, that is the first iteration, the second iteration, the third iteration, and so on. Then we have a column for the initial value a, column for the initial value b, c, f of c, then a minus b. So these two lines are to print these column names, alright, these two things. So this can be ignored for now. Then what I have done is I have created a while condition which checks whether the absolute difference between a and b is greater or equal to the desired accuracy. If it is greater or equal to the desired accuracy, that means that we haven't found the root yet. So what we will do is we will calculate c, that using the bisection method formula, that is a plus b divided by 2. Then I have done this pretty redundant step of making new variables. Fa equals to f of a, fb equals to f of b, and fc equals to f of c, which is pretty redundant and wasn't needed, but I just did it anyway so that I could avoid these brackets whenever I wrote fa, fb, and fc. Then I incremented this iter variable that I declared to be 0. Then okay, alright, so then what I have done is I have printed the iter variable that is now 1. Then I have printed the value of a with the space of 18 with 18 spaces between. Then after 18 spaces I have printed b, then after 18 spaces I have printed c, then f of c, then the absolute difference between a and b, which you can see right here, we print the iteration number, the value of A, the value of B, the value of C, f of C, and then the absolute difference between A and B. So that cout line is for printing this. All right. So where was I? Okay, so I printed this line. Now what we will do is we will check if f of c, since fc is equal to f of c, so I'm going to call this f of c. All right. So if f of c is equal to 0, then what that means is we have found a root, because the root of a function is exactly where the function returns 0. So if it is true, then we will simply print out that the root of the equation is c right here, and we will return 0 and end our program. Return 0 means that we are going to end our program. All right, it prompts the computer to just end it. Otherwise, what we will do is we will check if f of a and f of c, their product, is greater than 0, then that means that the root lies between b and c. I'm sorry, the root lies between c and b actually, because c is less than b. So since the root lies between c and b, we will make a equal to c, and if it isn't the case, then that means the root lies between a and b, therefore we will make b equal to c. This line is also pretty redundant. You could just use an else statement and then write b is equal to c. This if condition is pretty redundant in my opinion. Alright, I created this program long ago, and now I can see that there are quite a few redundancies. Anyways, they don't worry about that. You can sort them out yourself, whatever you feel like, but this program definitely does work. Alright, so don't worry about that. So all this was covered in the algorithm, so I guess this will be not very tough to follow. Alright, so now let me just go through this again. So if f of c was 0, then we printed the result right away and ended the program with return 0. Otherwise, we calculated new values of a and b depending whatever condition was fulfilled, and then whenever this absolute difference of a and this is this bracket is for this whole from here to this point is our while loop. All right, so this whole loop will be repeated and repeated until the absolute difference between a and b comes out to be less than the desired accuracy. If it is greater than or equal to the desired accuracy, this whole loop will keep on repeating until we get the desired accuracy less than we get the difference between a and b less than the desired accuracy. And as soon as that condition is fulfilled, that means that the root is now within the desired accuracy that user desired. So we will just print out the root of the equation is c. And I think that I have used an additional curly bracket here, so I'm not sure why I have used that. Alright, so that is for that else statement above, which since this else statement goes from there to here, so this is the while loop. Alright, this is the while loop, and from here to here we have the else statement, because the else statement is where our whole program is basically. Well, that's how you create the C++ program for bisection method, and let's just run our program now. Okay, so just compile the program first of all and then run it. So clearly the equation that I am using currently is x squared minus 4, as you can see right here, and we know that the roots are 2 and minus 2. Therefore the root, let's say I enter the initial guess as 1 and 3. Now we know that the root does lie between 1 and 3, that is 2, and let's say I use a pretty small accuracy, 0.001. then within a single iteration, within a single step, we have the answer 2. And why is that? Because when we calculate c, that is 3 plus 1 divided by 2, we get 2, and I already had a condition in my program that if f of c equals to 0, then that is the root of the equation. So that's why we got the answer in just a single iteration. However, now let's use a different value of initial guess, that is 0 and 5, and let's have an accuracy of 0.001. And now you can see that it took us 13 iterations to find a root that was correct up to 3 decimal places. Even though I only wanted a root correct up to 2 decimal places, I have still got a root that is correct up to 3 decimal places. Alright. Now let's use some other initial values like let's say -5 and -1. Alright. Now let's use an accuracy of 0.001, and you can see that within 2 steps I have got a root that is the exact root -2. So it is crucial to enter the program does depend a lot on the initial guesses, but don't worry, it will almost always converge to your root as long as that root lies between your initial guesses. And let's see another case where the root doesn't lie between the initial guesses. Let's say I enter the initial guesses as 6 and 10. Now I enter the accuracy as 0.001, and clearly you can see it prompts me to please enter a different initial guess because the root doesn't lie between 6 and 10. Now let me just use another equation right here. Let's say I use x cube is equal to 9. Alright, so this is my equation. Let me just save the program. Alright, now if I run the program, let me just break this here. Alright, compile the new program, run it. Now let's say I enter 0 and 50, taking a huge difference between the two values. Let's say I had a very complicated equation and I just wanted to be sure that I am covering the root between my initial guesses. So let's say I enter the second initial guess to be a pretty large value. Now if you press enter and enter the desired accuracy of 0.001, now you can see it took almost 16 iterations to find the root. Alright, so well, that's how you create a program for the bisection method. I hope you all understood that pretty easily. I tried my best to make you follow all the steps, and you can get all these algorithms and flowcharts and programs on my website. I'll make sure to mention the links in the description of the video, so just check those posts out on my blog or my website. So you can even leave any comments in the comment section below if you have any doubts or questions. And that's it for today. Thanks for watching, and subscribe to my channel for more videos like this, and like the video if you liked it. And that's it. Thanks for watching and have a nice day.